Okay, I believe by now you have my screen in front of you and my audio is clear enough. So today, being the 16th of August 2024, we shall proceed with our course, which is EDUC 801. And then we shall solve problems from the last topic, which was on measures of association. Basically, we spoke about correlation, which we gave the history of that. And the history of correlation coefficient actually came from variance. Through variance, we had covariance. And then when you standardize covariance, you have correlation coefficient. In fact, you have Pearson correlation coefficient. And when you square the Pearson correlation coefficient, you have what we call coefficient of determination. And that is where we stopped. All right? So by next semester, we shall proceed with prediction, which is on regression. So we are stopping this particular course on correlation. All right? So we have 30 questions here, if I'm not mistaken. Yep. So my plan is to solve 6 or 7 maximum because I want to use 30 minutes on this. And then if I'm solving 6, or let me say I'm solving 7 or 5 or 6. So that let's start with multiples of 5. So that will give us 6 questions to solve. All right. So that means I will be starting with question number 5. So question number 5 says, which of the following values of Pearson correlation coefficient indicates the strongest relationship between two variables? Please kindly unmute yourself and answer this question. This is very trickish. Please take note of this. Which of the following values of Pearson correlation indicates the strongest relationship between two variables? Yes, please. What is the answer?
B, sir.
So B, somebody say B. Any contrary opinion?
No. A.
Somebody
Yes,
say
I
A.
think B.
Somebody say A. Somebody say B. Any other opinion? Any other opinion? Contrary to these two?
No, sir.
Okay. Okay, great. Remember, Pearson correlation coefficient, it has values from -1 is less than or equal to R, which is less than or equal to 1. The closer the value to 1, the stronger the correlation coefficients. And when I say the value to 1, I actually mean the absolute value. The closer the absolute value of R to 1, the stronger the correlation coefficient. So somebody say A is 0.9, minus 0.9, in which this is very close to -1, right? And somebody say B, which is 0.85. This one is also very close to 1, all right?
Yes.
What if we take the absolute value of the two of them? The absolute value of minus 0.9 will give us 0.9. And the absolute value of 0.85 will give us 0.85. Okay? Okay. So which of these two now is the closest to 1?
No.
Is A or B?
A, sir.
Is A,
sir.
because 0.9 is greater than 0.85. Okay, so the correlation coefficient, which is strongest, is what? A, minus 0.9. But it is negative, right? That
Yes,
means
sir.
that the direction of the relationship is opposite to each other. All
Okay.
right? Okay. So the strongest Pearson correlation coefficient is minus 0.9. Thank you. I want to believe that is clear to everybody. So question number 10. Question number 10 says, in a correlational study between Twitter popularity and presidential election results in Nigeria, which outcome could be expected? Please, moderators, which outcome could be expected with a Pearson correlation of minus 0.65? This is another conceptual problem, talking about trying to seek your knowledge of interpreting this negative correlation coefficient. And it is between Twitter popularity and presidential election. A says higher Twitter popularity is associated with lower election results. B says higher Twitter popularity is associated with higher election results. C says Twitter popularity has no effect on election results. D says Twitter popularity predicts the exact election results. Which one is correct? Is A. Somebody say A. Any contrary opinion? No contrary opinion means you agree with this person, which is that higher Twitter popularity associated with lower election results. And that is correct. And how or why is the answer A? Any explanation? Who can explain why the answer is A? Because
the relationship is negative, linear negative correlation.
Yeah. I think that summarizes all. Yeah, negative correlation coefficients indicate opposite direction in the relationship. If one is higher, the other will be lower. Okay? So the two variables we have here are Twitter popularity and presidential election results. All right? So that means if one is higher, the other will be lower because the correlation coefficient is negative. Thank you. I think the knowledge is sinking now. That's fine. Let's go to question 15. Question 15 says, in an educational study, the coefficient of determination between hours of study and exam scores was found to be 0.64. What percentage of the variance in exam scores is explained by hours of study? Coefficient of determination. Coefficient of determination. Coefficient of determination is 0.64. So what percentage of variance does the two variables have in common? A, 36%, B, 64%, C, 80%, D, 40%.
Sir, 80%.
Yeah? 80%? Okay, somebody say A, I mean C, 80%. Any contrary opinion?
B, sir.
B, which is a 64%.
64%.
Excuse B, sir.
B, okay. Any contrary opinion? All right. So the person who said the answer is C, how did he get that 80%? Any luck? Can you explain? Maybe or maybe not. Remember in class, we say that coefficient of determination actually quantify the amount of variables, the amount of variance shared by the two variables in your correlation analysis. All right. And usually, coefficient of determination is expressed as percentage. All right. In which coefficient of determination usually is multiplied by, which is equals to R squared, is multiplied by 100% to give us the value in percentage. All right. So in this case, coefficient of determination is given to be COD is given to be 0.64. So when you multiply this by 100% times 100%, you're gonna have, whenever you are multiplying by multiples of 100, multiples of 10, what you just need to do is to shift the point forward in accordance with the number of zeros. To shift the point forward in accordance with the numbers of zero. In this case, we have 2 zeros, okay? So I will just shift the point forward 2 times, 1, 2. So therefore, the point that was initially after 0 is now after 4. So this is equals to 64%, all right? Okay, so the answer is 64%. Okay, let me quickly chip in something. What if the question is, given the coefficient of determination to be 0.64, what is the correlation coefficient? What is the correlation coefficient? Given the coefficient of determination to be 0.64, what is the correlation coefficient? This is a point where you're gonna use this formula. Where is it? This formula I wrote here. That coefficient of determination is equals to R squared, where R is the correlation coefficient. That means R squared in this example is going to be 0.64, okay? And R will be the square root of 0.64, okay? And the square root of 0.64 is what? 0.8, right? So R is 0.8, okay? So the correlation coefficient between the two variables is what? 0.8. Is it okay, everybody? I want to believe you remember how to do this type of a square root without using a calculator. This one is just the square root of, you change the decimal to fraction. That would be 64 over 100. Okay? And then you find the square root of 64 divided by the square root of 100. The square root of 64 is 8, because 8 times 8 is 64. And the square root of 100 is 10, because 10 times 10 is 100. So R is equal to 0.8. Okay? Without using any calculator. That's fine. I hope that is okay with everybody. So we can go to the next question. That is question number 20. And it says, if a correlation study finds that the correlation coefficient between teacher experience and student performance is minus 0.3, R equals to minus 0.3. What does this imply? Nice one. If a correlational study finds that the correlation coefficient between teacher experience, for those that will be looking for experienced teacher, now they are saying the correlation is negative. So if the correlation coefficient between study finds that the correlation coefficient between teacher experience and student performance is minus 0.3, what does this imply? A, More experienced teachers are associated with better student performance. B, less experienced teachers are associated with better student performance. C, teacher experience has no impact on student performance. D, teacher experience is directly proportional to student performance.
C.
C, somebody says C. Any contrary opinion?
Yes, associated with better student performance. Why is it? Less experience associated with better.
D.
Somebody say B.
No, not B. D.
D, okay, D for dog.
Yes.
Somebody say D for dog. Any contrary opinion?
Excuse C, sir.
Somebody, we get all the options today. Somebody, C, we have C already on the board.
Okay.
Huh? Any contrary opinion? Okay. So let us analyze the first answer, which is C. C says teacher experience has no impact on student performance. Before you can talk about this in any correlation study, the correlation must be what?
Zero.
Must be zero. If there is no linear relationship between your variables, the correlation must be zero.
Zero.
But in this case, the correlation is not zero. It is minus 0.3. So the answer cannot be C. What about D? D says teacher experience is directly proportional to student performance. No. Every correlation will tell you about linearity, that it is proportional. But this one is negative in particular. You need to do more. Okay? Negative correlation means what? Can you remember?
Yes. Opposite direction.
It means opposite direction. If one is high, the other will be low. Let us now see option A. More experienced teachers are associated with better students. It means experience is high and performance is high. Is that not?
Yes.
This
That is not the answer.
This one is interpretation
That was not the
of
answer.
positive. This is interpretation of a positive correlation.
Correlation, yes, sir.
What about B? Less experienced teacher are associated with better student performance. This one is low against high. Is it not?
Yes.
So this is opposite direction. When one is low, the other is high. When one is high, the other is low. So the right answer is B. Less experienced teachers are associated with better student performance. Or you can say it in another way. More experienced teachers are associated with low student performance. It must be opposite. Huh? Thank you. We now go to problem number 25. So the answer is A. ANS is what? Oh, sorry, is B. ANS is B. The next question here says, which statistical techniques would you use to assess the relationship between a continuous variable and a dichotomous variable? A continuous variable and a dichotomous variable. Yes. This one is coming directly from your note. The last part of the note speaks about this. What is the answer? I think I should leave the answer to you. Check your notes. So that for those that are not reading, for those that no, madam, just keep the answer to yourself. Check your notes for those that are not reading the notes, so that they will be forced to read the note to know the answer. Let's go to question number 30.
You are owing us one question to answer.
Eh?
You are owing us one question to be answered.
Yes, so that you also take responsibility, yes? Okay, let us take question 30. A researcher finds a Pearson correlation coefficient of minus 0.45. R is minus 0.45. Between student screen time and their reading comprehension scores. That is how much time they watch their phones. You see this type of study. How much time they read from their phones, or they watch television, or they watch their laptop. A researcher finds that there is a Pearson correlation coefficient of minus 0.45 between student screen time and their reading comprehension. What percentage of the variance in reading comprehension can be explained by the screen time? What percentage of variance in reading comprehension can be explained by the screen time? First and foremost, when you are hearing this type of percentage of a variance shared by two variables that are linearly related, your mind should go to which statistic? Your mind should go to which statistic? Your mind should go to where?
No.
Coefficient of determination. Coefficient of what? Determination. Whenever you are talking about the variance shared by two linearly related variables. So in this case, now you are given the coefficient of the correlation coefficient. Now you look for coefficient of determination, which is equals to R squared. And if you are putting it percentage, it's going to be multiplied by 100%. So this will be minus 0.45 squared multiplied by 100%. And this is what is minus 0.45 squared? Tell me the answer. 0.2025, right? Multiply by 100%. Whenever you're multiplying by a multiple of 100, you shift the point forward, a multiple of 10. You shift the point forward in accordance with the number of zeros. Here we have 2 zeros, so I just shift 1, 2. The point that was initially in front of the first zero is now in front of the second zero in the number. So coefficient of determination, or the percentage of the variance shared by the two variables, is what? 20.25%. So the right answer is what? Is option B. Are we okay, everybody? Are we okay, everybody?
Yes, sir.
Good. I promised to solve those 6 questions, so I'm leaving the remaining questions for you to look at. But let me just skim through and see if I get something here. Okay. Let me take question 29. It's like we have not taken this example. Question 29. Look at this question 29. It says, suppose the covariance between time spent on online educational platforms and student final exam score is 3.5. Covariance is 3.5. And the standard deviations for these two variables are 1.75 and 2.5. SX is 1.75. SY is 2.5. Calculate the Pearson correlation coefficient. By the formula, correlation coefficient is covariance divided by the product of standard deviation. Okay? Our moderators, please do your job. So, when you standardize covariance, you get correlation coefficient. So this will give you covariance is 3.5 divided by SX is 1.75 multiplied by SY is 2.5. Okay, please. 3.5 divided by, press your calculator, let me know. What is 1.75 divided by 2.5. 1.75 multiplied by 2.5. What do you get? 4.375. Thank you very much. So now when you divide 3.5, you get what?
0.8.
0.8. Perfect. So the answer is exactly 0.8. So the correlation coefficient between the two variables is 0.8, and the right option is option B.
3 point.
Are we okay, everybody? You can see how easy this thing is, how you can move from one equation to another. Is it okay, everybody?
Thank you, sir. Yes.
All right. Thank you very much. So this is a point where we are going to stop. We use the remaining few minutes to talk a little bit about the test we did yesterday, right? Looks like it is far. It was just yesterday. And then the exam that is coming up next week, Thursday.